The ACME project is a project in several years in the making where we're working to study various forms of gaseous diffusion flames, learn more about efficient energy production and pollution control. The ACME experiment has broken into 5 separate sub-experiments, each of which address different aspects of fire and fire safety. 4 of them are really focused on pollution control, energy efficiency through different kinds of experiments. Some are reference experiments designed to produce data sets that be amenable to later analysis, and others are looking at particular phenomena and specific issues that control flame stability or soot release. And finally, one is addressed towards fire safety in spacecraft and trying to see if there's a good model we can use on the ground for spacecraft flammability. All of the experiments use gaseous fuels in a gaseous ambient environment. And there are what we call diffusion flames, which is where the fuel and oxidizer are not pre-mixed before combustion. So they then merge by diffusion and form the flame boundary. However, after that, the similarity ends. So we have spherical flames suspended about burners, we have gas jet flames, and we have even flames where we've inverted the background so the fuel is in the ambient and the oxidizers coming out the nozzle. These are carefully crafted experiments where we've spent years refining the way we'll do the experiments in the test matrices and how we can merge them all into one piece of apparatus. And those combined experiments will all execute sequentially with teams on the ground working with the astronauts to ensure we do make the most efficient use of the time we have on orbit. This insert will go in the SIR chamber with the associated burner for each experiment. And the crew will set it up for us, install the gases, and make other connections necessary. And then it will be teleoperated from the ground here at NASA Glenn. And so the principal investigators will have immediate access to the data from each test and can use that to control the next test point. Each of the ACME experiments, of which there are 5, all have university principal investigators, and they have often other co-investigators, comprising a large team of investigators that will be actively tracking every test point and comparing to their models to pick the best test points as we go.